I want to talk about beef cattle supplementation, and I don't really want to get much into kind of the historical stuff about beef cattle supplementation around how much protein do we feed, when do we feed protein, all those kind of things. I kind of want to take it a little different direction. I think maybe a little more next gen kind of supplementation kind of thoughts, and share with you my approach to what I'm doing in my research lab, and where I think is an interesting place to go in the future around beef cattle supplementation and general management in grazing systems. And so that's kind of why I picked this title here, Finding Win-Win Solutions to Improve Sustainability in Grazing Systems. And so we'll talk just a little bit about that on introduction, and then get into some results of the research that we're doing here at OSU. So for an outline, we're going to talk just a minute about sustainability. I want to tell you some of the objectives that I have for my research program, and then talk about the strategies that I'm employing to try to meet those objectives, and kind of why we're focusing on supplementation a little bit in grazing systems for these objectives. Give you some data on some experiments we've done recently, and then talk about where we're headed in my lab in the future. We'll jump into sustainability just for a little bit of background. And this is, a lot of people are probably tired of hearing this word and tired of talking about it, and a lot of farmers kind of are too. But I really think it's an important topic, and it's a meaningful topic. And I think the important thing to remember about sustainability, especially when you're talking with farmers and ranchers, is that it's not just about environment, right? And so sustainability really has three components to it, and many of you have heard this speech before. But there's the economy, there's the society, and there's the environment that are all basically equal components of sustainability. And another Venn diagram of how to show those is that sustainability is really the intersection of improvements in environment, improvements in economics and finances, and improvements in the social aspects of the way that we do things. And if you miss any one of those, if you miss improving any one of those areas, you haven't hit sustainability. And you may do some positive things, but if you don't hit every one of those areas, you haven't hit all the legs in the stool of sustainability. And so that's important. That's why I'm talking about, and several times I'll talk about win-win solutions. And what I mean by that is trying to find solutions that hit multiple aspects of sustainability. We're always worried about making money, but we also want to improve the environment, reduce our impact on the environment, and we want to improve our social standing in society. And so we're always trying to find win-win and even win-win-win solutions that we can hit all of those. Okay, so that's a little bit about sustainability. So what are the objectives? And these are kind of the big, broad objectives that I have in my program. And the big one, the first one, is to improve grazing system sustainability. And so that's, I think that we can have that objective forever. Sustainability is not really a destination. We're not ever going to get there and say we're done. We're always going to be able to improve, continuously improve things around trying to continue to be more sustainable. And so I think that's a long-term objective. Again, we want to improve the financial aspects of grazing systems. We want to improve production. We want to have more food available, more animal products available to consumers. We want to improve the logistics. We want to make it easier and less stressful for ranchers to operate these systems, and we want to continue to improve the environment, whether that's soil, water, air, any of those aspects of the environment. We want to continue to improve those, biodiversity, all of those. The second objective is kind of related to that first objective, but my second objective for me is to, as I'm working in grazing systems, is I want to train and inspire students to learn next-gen science skills. And what I mean by that is that I think there, especially around technology and around managing data, there are skills that are going to be increasingly required of students and scientists going forward. We're going to produce a lot more data. We're going to have a lot more data available to us, and we need to have our scientists and even our producers developing the skills to be able to use that data and make better decisions and not get overwhelmed with the mass of data. And so part of my objective is to train myself and continue developing those skills in myself, but also train and inspire students with those skills too, as we're working in grazing systems. So those are the big overall objectives. So what are the strategies that we're going to use in my lab to achieve those objectives? The first strategy that I work on a lot is precision management, and I think this is a key area. To me, it's timely, it's right for developing in this industry. We've seen a ton of improvement in efficiency and in production, in precision management, in agriculture in lots of different ways, but especially in cropland agriculture. Precision farming has been a real boon, and I want to take those same concepts and apply them to grazing systems. So how can we do precision management in grazing systems? And I think there are a couple of key components that you want to think about when you're doing that. In grazing systems, when we're talking about precision management, we want to be able to influence and more or less try to control how the animal grazes, how, where, when, what intensity, and try to have tools that let us have more control over how the animals utilize and interact with the landscape. And hopefully, if we have the power to control that, we'll make good decisions about how to influence that in the animals and improve all those aspects of sustainability. A second area around precision management is precision supplementation, and I think this is one that's really fun for me. You know, the historical approach to supplementation. In managing supplementation in grazing systems, we have determined, estimated what we think animals need as far as supplements in grazing systems by doing research and then taking averages of many studies and building models so that we can say what the average animal needs in the average situation. And on the average, those models work really, really well. But the question becomes, what if we have situations or animals that differ from the average of the situations that produce the model? How do we adapt to that? And I think that we have traditionally said that we're going to supplement, we're going to manage supplementation on herds of cattle at a time, and we're going to manage that on a time scale of months or seasons of the year. So we're going to find a supplementation program that fits with this herd of 200 cows for the winter, and that's our supplementation program. And the precision management part is going to come in. What if we can do a lot more precise than that? And how much efficiency can we gain by doing that? And I think there's some to gain there. So control of grazing and supplementation are the real aspects of precision management that I think are that we're working on, that I think are the most fun, probably have the most potential to help improve these systems. And the way that we're going to do that, you could probably guess, is to try to incorporate technology and real-time data analytics into how do we make the decisions to control those things? How do we recognize that we need to change something about grazing or about supplementation? And then how do we, once we know that we need to change something, how do we apply it and get it to actually change in a precise way? And so we're going to talk about that for the rest of the seminar today. The theme is, or a lot of the theme is, incorporating technology so we can make better decisions. We want to make those decisions faster and more accurately. And then one of the things too, and I mentioned it before, but you know, there are lots of logistical challenges in managing grazing systems. There's fewer people, less labor, everybody's busy and got less time. A lot of our ranchers are older, and so there's lots of logistical challenges that I think we can use some of this technology to address those logistical challenges. And it may be that some of the ways that we can make the most impact on ranchers' lives and potentially make an impact on their finances is to help solve some of these logistical challenges about knowing where animals are, knowing the health status of the animals, knowing where they need to focus their management attention at any one time. And so those are all parts of the strategy. Okay, here's a couple of questions that I think about that kind of motivate me to tackle some of these things. So we know that there are lots of management practices that are best management practices, and we kind of in the commercial ranching industry, we know about what we can do today. We know the capacity that we have today as far as managing animals, and we talked about that in supplementation, about supplementing herds of animals for a month or two before we change our management system. But if we didn't have those limitations, if we had the capacity, if we could supplement each cow that we have each day exactly what she needs that day and no more or no less, what would the results of that be? We don't have this capacity commercially today. But if we did, what could we get? How much feed could we save if we could do that? How much more production could we get out of certain cows or the average of our herd? How much can we influence production if we had this capacity? Okay, another question. If we could make cattle produce less methane, we're going to show a little bit of that. It's kind of hard to do that today. We don't really have the capacity to do this, I don't think. But if we could do this, if we could make cattle produce less methane, less enteric methane, would they be more efficient? Would they be able to capture that energy that they're wasting now and be able to turn it into gain? Would they have less impact on the environment? We think the answer to those questions is yes, and that would be beneficial. So we need to develop, if we want to do that, we need to develop the capacity to make cattle produce less methane. Maybe we can do that through precision management. Here's another one. If we could track cattle movements in real time, cost effectively. We don't have a way to do that today. We can't afford to put an iPhone on every animal and do like you track your kids or whatever. We can't afford to do that, to know where every cow goes all the time. But if we had sensors that were cheap and cost effective and rugged, and were able to tell us in real time where our cattle go, what could we do with that information? I think there's lots of things we could do with that information. How much easier would it be? Imagine a large ranch, or imagine your family members or ranchers that you know, and the time that they spend, the fuel that they spend, just going and finding cattle to check on. How much easier would it be if we knew exactly where they were in real time? How much labor could we save? How much loss could we prevent? Could we address stray animals more quickly, or theft, or any of those kind of things? So those are some of the logistical problems that I think we can also address with this precision management concept. Okay, so that's kind of the introduction. So let's talk about supplementation a little bit in precision management. And when you're talking about supplementation of animals, really what you're talking about is knowing how much supplement animals eat, and then eventually controlling how much supplement they eat. And the standard way that we provide supplementation to animals today is however big the pasture is determines how many animals are in the pasture. And you'll have a trough, and basically you just go out in the pasture and pour out supplement and you've calculated that if every animal needs 2 pounds of supplement today, you just multiply by the number of animals, and you pour that much out in the trough and watch them eat. And that's basically our approach to supplementation. And you may come back tomorrow and do the same thing, or you may come back in 3 days and do kind of the same thing, or some people do that once a week and pour that out. And so that's our level of supplementation management today. And I think we can get a lot more precise than that. If we want to get more precise than that, we got to measure the supplementation going into animals and eventually control it. So, the old cliche, you can't manage what you don't measure. It's a cliche, but it's a cliche for a reason. It makes sense. So let's talk about supplementation measurement. This is a piece of equipment that we've got that was manufactured by a company in South Dakota. This is called a smart feed, and if you've ever seen a GrowSafe system or an Intech system, this is kind of doing about the same thing. It's a little bit more portable than a GrowSafe system, but basically it's a feed bunk, and we put supplement in this apparatus. And as animals come to it, they can stick their head in there. It reads an ear tag, and it knows this whole stainless steel bin is suspended on load cells, and the computer is measuring how much feed the animal eats. And we've done this. We provide supplement this way in grazing systems. We put this out in pastures, or put it adjacent to pastures where animals can come in and consume supplement and then go back out and graze. And so this was kind of the prototype one that we first started with. This is one of the original smart feeds, the first one that we got a couple of years ago. And I'll show you a little bit of data that we get from that. This is an example of an experiment that we did. We fed 15 steers, had them grazing in a native range pasture in the spring and early summer, and then well, this was at the beginning of the spring here in this part, but you can kind of see for each animal we know how much supplement they ate out of that feeder every day. This supplement was limited with salt. We'd mix salt in it to try to control the amount of supplement that animals consume. Salt limiting supplements is a really common way historically of trying to control supplement intake. We were curious to see how well that would work. And so you can kind of see that there's quite a bit of variability in intake of supplement among these different animals and over time. And so we've got 15 animals here, and you can probably see that 13 of those animals did about what we would expect them to do. And in 13 of these animals, there's maybe not a lot of a super amount of opportunity to improve efficiency in 13 of these animals, but in 2 of them, it looks to me like there is opportunity to improve efficiency. There's one right down here at the bottom where this animal never ate a bite of supplement. And so I think we potentially gave up some performance right here that we could have gotten if we had figured out a way to make sure that this animal got what it needed in every day of this grazing scenario. And the data shows us right here that I think he did not get what he needed in that system. And I think this happens. You have animals like this in every herd that don't eat the supplement that you put out for them, and you're losing efficiency with those animals. And so we can see that here with this system. And then right next to him, this animal, the second animal, apparently was a salt addict, and for some reason was able to consume had a very high tolerance for salt and really ate our supplement. And this animal ate way more supplement than it needed, and there's no way this animal could gain enough to make this amount of supplement intake efficient. And so we were wasting supplement here on this animal. And I think there's animals like that in every herd too, that are hogs that eat way too much, and we need to put those animals on a diet so that we can get the efficiency out of them and avoid wasting this supplement cost on an animal that can't use it efficiently. And so that's some of the preliminary data we got, and I think kind of reinforced some of this thought process of trying to improve precision in supplementation. Okay, here's a summary that we got from that study, and we're working on getting this. We got this manuscript in review right now to be published in Professional Animal Scientist, and so we're hopeful that's going to happen. But what we're seeing here is the effect of the variability of supplement intake over time on efficiency. Okay, so we basically had 2 treatments in this study. We had cattle that we let come in and eat out of that feeder, and basically they ate what they wanted to eat, and you saw the variability that those cattle had in supplement intake over time and between animals. And then we also had the same animals, the other treatment, where we put animals in a stall and hand fed them exactly what we wanted them to eat. So we individually fed all those animals, but we were in control of what they ate. So they had no variation in supplement intake. We decided what they ate every day, and we controlled it. And so I was interested to see in those two approaches, how does this, who's more efficient? If we let the cattle decide what they want to eat and they're variable, is that okay? Or if we decide what the cattle eat and we control it, are we more efficient? And I think we were able to get some indication here that it's better if we control the variation, if we can manage and control the variation. Because if you look over here on the left side of this graph, all these dots over here are the animals that we controlled the supplement intake, and they had no variation within a week. And then the response variable here is supplement conversion efficiency after we take out the effects of differences in supplement intake. Okay, so I really wasn't concerned about the amount of supplement that they ate and what that effect was on efficiency. I was concerned about the variability of the supplement intake and how that impacted efficiency. So we've got animals over here that have no variability, and then these animals over here were the ones that got to pick whatever they wanted to eat, a lot more variability. And you can see we had a trend there for efficiency to get worse as the animals made the decisions and were more variable in their supplement intake. So this kind of I think is a beginning to show us some evidence that if we can control it and do precision supplementation, there's efficiency to be gained there. So that was one study that I wanted to show you. Here's the next version of that equipment. We've got a couple of trailers now that have those feeders in them, so they're much more portable. And we've got them out in grazing systems. I'll show you a little bit of what this looks like when animals use them, and the upgrade here. Turn that down a little bit. But this is an animal using the feeder in the trailer when it's out in a pasture. They certainly like the feed, and they'll crowd around, and there's a little bit of competition to use the feeder. And you'll see here in a minute, you may have seen at the beginning, if we watch long enough, on this upgrade version of these feeders, there's actually a gate. You can see the gate moving right here. And as the animal leaves, that gate will close. And then when an animal comes back to get into the feeder, the computer will read its ear tag and determine if that animal's eligible to get more feed today. And if it's eligible for more feed, it'll open the gate and let that animal back into the supplement. And so this restriction gate here is the first wave that we have of controlling supplement intake. So not only are we measuring supplement intake individually every day, but now with that gate, we're controlling supplement intake individually every day. And so this is a tool we're working on to help us do precision supplementation. So we've got a little bit of data too from this that I think is interesting. We've got 2 of those trailers with 4 feeders, and this just shows you some data that we got from cattle that were in those areas with those feeders and some of the intake over time. And these different color lines are the different feeders. And so we'd always heard that, or I'd always heard that cattle get accustomed to eating in one spot, and once they learn how to eat out of one feeder, they'll only use that feeder, and they won't go look for another feeder. And we just the data that we have says that's really not true at all in our system, and they'll every animal was going and trying to get feed out of every feeder. So I thought that was an interesting data point that was contradicted a bias that I had previously. But we got, these systems produce a lot of data, so there's lots of different ways lots of different interesting questions you can ask.
Speaking of questions, Ryan, I have a question. Okay, just in terms of how that feeder works, so it just determines whether or not a cow can get back in, right? So does it just is there anything to cut them off if they've had their head in there for a really long time?
Yeah, there actually is.
Okay, I was like, once they're in, are they in until they're done? Or?
Yep. Some of the other systems that do these kind of things, they all have little quirks in how they work. But this one, the way they manufactured it, when the animal reaches its limit for the day, there's actually an actuator in there that will physically close the door and push the animal out of the feeder. So that's really handy for doing low dose supplementation type things.
Gotcha.
Cool, good question. Okay, so we talked a little bit about supplementation control. So we get in, some of the other research we've done is around enteric methane mitigation. And so, you know, we're trying to develop ways to control supplement and do precision supplementation. Why, you know, so the question might be, well, why would we want to do that? Well, one reason we might want to do that is to provide some targeted strategic supplement to mitigate enteric methane emissions in cattle. So we've worked on methane mitigation as well. And so we've got a little bit of data to show you on that. Most of you probably familiar with this system. This is a green feed system. It's manufactured in South Dakota by the same company that makes the smart feed system. This was kind of their original product. And our green feed system's mounted on a trailer, and we put it out in pastures. It works really nice. And this system works by providing a bait supplement to the cattle. And so they come visit this feeder, get a little bite of a bait feed, and then it has a fan that pulls air in and measures the methane, carbon dioxide, and oxygen concentrations of the air when the animal's at the feeder and when it's not. And so by doing some algorithms, you can figure out what the animal's methane emissions are with this equipment. It produces some really nice data. So we've used that in a couple of experiments. Matt Beck was a former graduate student of mine, and did a couple of experiments where we used fat supplementation as a way to mitigate methane. There's some research that would indicate that fat, if you provide fat, that tends to, or potentially has an effect to reduce methane emissions from ruminants. And so the study that he did was feeding whole cottonseed supplements to steers that were grazing. And this shows you, we had 18 animals in this study. We had 3 that were on controls that had no supplement. We didn't show those, but you can see we had 3 animals assigned to different levels of whole cottonseed supplementation. So if you offered 1 kilogram down here at the bottom, if you offered 1 kilogram of whole cottonseed, cattle ate all of that. And we offered this supplement in individually, kind of the old traditional way, in individual stanchions, feeding stanchions every day. But if you offer 1 kilogram, cattle will eat all of it. If you offer 2 kilograms per head per day, they'll basically eat all of that. If you offer about 3 kilograms per head per day, they'll eat most of that, kind of average about 2.5 kilograms, but there'll be a little bit of refusal. And then if you keep increasing the amount of whole cottonseed that you offer, you just can't get cattle to keep eating it. They stop at about 2.5 to 3 kilograms of whole cottonseed. These size of cattle, these were 800 pound steers. These kind of cattle will stop at about 3 kilograms of whole cottonseed supplement a day. But you can kind of see what those intake curves look like. So we offered this whole cottonseed supplementation, and then we measured exactly how much they consumed and used their actual consumption to try to see what impact we could have on methane emissions. And this is some data that is related to that. You can see here that we've got 3 panels. The top panel is average daily gain. The middle panel is methane emissions. And then the bottom panel is emission intensity. And we'll come talk about that here in a minute. But you can see that supplement, as cattle eat more whole cottonseed, they gain more. That's pretty standard. And then, we kind of found this interesting response in methane emissions. So we seem to have an effect where we could reduce methane emissions a little bit out here at a moderate rate of whole cottonseed supplementation. About 2 kilograms per head per day kind of minimized our methane emissions. One issue we had with this data, we've only got 1 point over here at control where we had 0 supplement intake. We had 3 animals here. One of those animals died from an unrelated cause early in the experiment. And one of the other animals, even though it had been using the green feed up to this point, when we started the experiment, it refused to go use the green feed again. We didn't get any methane measurements of that animal. And so we eliminated those 2 animals from the study, and then we just had this one point out here that we weren't very confident about, and so it kind of created some heartburn of what we were going to do with this data. But what we ended up doing was just excluding this point, and it limited our inference a little bit, but we or significantly, I guess. But we could talk about, if producers decide that they want to feed whole cottonseed as a supplement, we could talk about what effects supplementation would have on methane. And a lot of producers would like to use whole cottonseed as a supplement because of the response that you see in gain. And we know that supplementation improves gain. So if they are going to supplement, then we had good data to talk about what happens to methane. And we can see that we reduced it here a little bit. This panel down at the bottom is emission intensity, and this is the grams of methane per kilogram of average daily gain. And so it's the middle panel divided by the top panel, and you can kind of see the shape that we had there. About 2 kilograms of supplement intake minimized emission intensity. And this is a variable that we're interested in because we think it's a pretty good proxy for sustainability, because we're getting environmental impact and performance and financial return in the average daily gain. And so we're combining those 2 things together. And if we can improve emission intensity, then we've got a win-win. We've made more money, we've produced more food for consumers, and we've reduced the environmental impact of that food production, or that food that we produced. So that's why we like emission intensity. It's a proxy for sustainability in some of the work we're doing. So that was one study that we were working to get that data published, and really enjoyed working on that study. Matt followed up with another study after that to try to understand, is the form that the fat is in, does that have an effect on these variables? And so we know that the fat that is in whole cottonseed, there's a significant amount of fat in it. That's why we fed it. We know that whole cottonseed, the fat in there is kind of bound up inside the seed, and some of it is ruminally available and some of it may not be, depending on the rate of passage and all those kind of things. So the question was, does the form of the fat have an effect? And so we fed some cattle. We did another experiment where we had cattle that were controls that got no supplement. We had cattle that got whole cottonseed at a fixed rate. And then we got cattle that got a supplement that was formulated to be nutritionally similar to whole cottonseed, but the fat came from soybean oil that we poured on top of the supplement. So it should have been totally available. It wasn't bound in any way. And then we had another supplement that was the same supplement, but the fat came from bypass fat, so that it basically was not ruminally, we assumed it was not ruminally available. And so those are kind of our treatments to see what effects those different forms of fat might have on methane emissions. And what we found is that, again, the whole cottonseed increased average daily gain over the controls at about 0.2 of a kilogram. We expected the other 2 supplements to do about the same thing. They should have been providing about the same amount of nutrition, but we found that those other 2 forms of fat actually increased average daily gain even more, an additional 3 kilograms a day. So we were kind of surprised by that. The whole cottonseed reduced enteric methane emissions by about 15% over the controls. So that's about what we expected. We expected that the soybean oil would do about the same thing, and maybe the bypass fat really shouldn't have much of an effect on methane emissions. That was our hypothesis, but what we found is that none of the other supplements had any effect on absolute methane emissions per day. So neither the soybean oil or the escape fat changed methane emissions from controls. Okay. And then again, we think about sustainability. All of the supplements reduced emission intensities. But when you look at these big effects, whole cottonseed reduced emission intensity about 34%, principally by reducing methane a little bit and improving gain a little bit. And the other fat supplements reduced emission intensity 60% because they had this huge effect on gain, even though they didn't affect absolute methane emissions very much. So all of these supplementation approaches improved emission intensity, and that's a theme that we found in several times, that supplements and even our standard industry best management practices tend to improve gain, which tends to dilute methane and improve emission intensity. And we found that repeatedly in several studies. So that's kind of a summary or a theme that we've gone on with. That we collected a lot of other data in this study about dry matter intake, the level of fat in the diet and what effects it had on methane, the digestibility of fiber fractions, and we'll work on making this data available. But one thing interesting to point out is just how much variability we see from one animal to the next in methane emissions. There's a lot going on with controlling methane, and so these are the kind of variabilities that we see when we're looking at individual animals. So if we're trying to manage and do precision supplementation on an individual animal basis, we probably got our work cut out for us trying to deal with the variability that comes with comparing one animal to another. But that kind of gives you an idea of some of that data. Another experiment that we did, and I'll try to get through this one pretty quick. We did another kind of a study in the same theme on wheat pasture, but instead of fat in this system, we did our traditional best management practice supplementation program for wheat pasture, which is an energy supplement with monensin, and we wanted to know how does that affect methane emissions. And this Logan Thompson, who's now at Michigan State, did this study when he was here getting a master's degree. And this is kind of one of the key takeaways that we got out of that study. And what you can see here is that as we fed supplement to those animals on wheat pasture, we see this downtrend in emission intensity. And again, that's the same thing that we found in several of these studies. When we do our best management practice that improves gain and is generally profitable, when we do that, we also see that we're improving emission intensity and improving sustainability of these systems. And we've seen that consistently. So just to wrap up, supplements improve average daily gain. We found that. So I'm waiting on the Nobel Prize Committee to give me a call for uncovering that finding. We may try to get that published in Nature or something. That supplements improve average daily gain, but more about sustainability, we found that these supplements, because they improve average daily gain, they reduce methane emission intensity, which improves sustainability. Methane emissions themselves are variable and complicated. I showed you some of the variability that we see in that data. There's lots of factors that go into determining what the methane emissions of an animal are, not the least of which is just the inherent variability of animals. And so we found that we need large studies, larger than probably what we've been doing, with long measurement periods. And we need to measure multiple variables with forage intake, supplement intake, the fat content of the diet, the specific dose of the ionophore, the baseline emissions of the animals prior to receiving the treatments, use those as covariates. So there's lots of variables that we feel like we need to measure to try to corral this variability that we see in methane emissions, so we can try to get meaningful results out of these. And then what I found so far with the approaches that we've tried is that it may be difficult to drastically, directly reduce enteric methane emissions of these animals. We can improve emission intensity, but it's hard to really reduce methane emissions. And maybe we need some new technology, a new feed additive, or a new approach to try to address that issue directly, if that's something we want to continue to try to do. So that kind of is a quick summary of where we've been. I'll show you a little bit about where we're headed, and then hopefully get some good discussion going. So where we're headed, we're going to continue working to try to find win-win management practices in these grazing systems. We want to continue to take data and try to turn it into information so that we can make better real-time decisions and help ranchers do that. we want to automate the time-consuming stuff around managing these grazing systems. And so as we're trying to be more precise and use more data to make better decisions, we don't want to just dump that off on the rancher that they have to do a lot more work. We want to build the whole system so that we can automate applying the precision management that we can figure out that we need to do. And so it's kind of a whole package, but that's really where we're headed. And eventually we want, we're always trying to get to this. We want safer, more productive cattle in better functioning landscapes with happier people. And so that sounds like a great world to me. And so we're always trying to head in those directions to hit all of those things and improve sustainability with all of those. You've probably seen something about this or seen this concept, but this is something that we're working to develop kind of in parallel with the supplementation thing, and the precision supplementation is part of it. But I think there's real potential in having systems where you have suites of sensors that are measuring things about the animals and about the landscape and about the interaction of the two and markets and all those kind of things to be able to develop a system that helps you accomplish this integration of technology and do it in a way that's easy to use and fun and profitable. And so several of my collaborators and I have worked on this for a long time. This isn't my idea. It's not new, but it's something that we're working on to continue doing in the future. So I mentioned collaborators. I've got lots of really good research connections that have been really thankful to have to help do a bunch of these things. We've got great collaborators here in the department, across OSU and in Natural Resources Ecology and Management, in Biosystems Engineering and Computer Science. We've got Corey Moffitt and Stacy Gunner out at Woodward at ARS, and good collaborators at El Reno in the ARS, and that's been really beneficial to our program. We've got great collaborators at Arkansas, Mississippi State, at OU, and other universities, and really good relationships in the industry with people that are trying to develop these things too and get them where they're able to be used commercially. And so, I wanted to mention that and say that it really takes lots of different people in lots of different areas to help push these things forward. This isn't all of the people that were involved, but this is a bunch of them, and certainly have a good crew and really enjoy working with them.